Okay, so we are recording. Yes, we are recording. All right, this is our week, our second week dealing with regression models in SAS Enterprise Minor. Of course, this is the week that at the end of this week, your second assignment is due. Now, you may have noticed if you were reading the discussions or, well, it'll be on the slide later on tonight, but I basically finally realized that this weekend is the 4th of July, and I want people to celebrate our country's birthday. So I've delayed, if you need it, I've given you until Tuesday, so it would be July 7th, to submit that assignment without any penalty. So, if you have something planned, a barbecue or fireworks or something, please enjoy that. I don't always feel guilty if I'm the one that causes a holiday to be messed up. We messed up Father's Day, so we don't need to mess up 4th of July too, so okay. All right. Now, I'm trying to do something tonight. Let me go to the next slide. I'm going to talk about regressions and show you a few of the things in Enterprise Minor. Of course, I don't think I've mastered anywhere close to all of the options or understand all the options, but there's a lot. But I know the basic ones, and I know the ones that you normally would use. Remember, SAS tries to give you, with the defaults, the most commonly used settings. That doesn't mean there aren't different ones you'd want to try, because the commonly used settings don't always apply or don't always give you the best answer. And so, you tweak a few things, you try a few things. And as I've repeated thousands of times already, it seems like, because it does all the heavy lifting, we just have to build a lot of models and then sort them out based on some accuracy measures. So first nice thing is that SAS will recognize, based on your target variable, whether you need a linear or logistic regression. So you don't have to even be concerned with that too much. So if your target is categorical, you'll get a logistic regression automatically. If it's a continuous variable, the target, you'll get a linear regression. What I'm going to try to do then is do a little walkthrough demo. Now, to protect myself against overly long delays running SAS Enterprise Minor, I've got some static screenshots throughout the presentation tonight, and then we'll get to some miscellaneous things. So if you may notice, I have my SAS Enterprise Minor open. Now, what I'll probably need to do is close the chat and window just so we can all see the whole window there. So I've got it open. We'll come back to that. Okay, remember our objective. Our objective is to come up with a mathematical model. Unlike a decision tree, which has a flow chart and a set of basically rules, we want to come up with a mathematical model that fits a plane, a hyperplane, to the multidimensional space we have the best it can. And again, it's equivalent to the best regression line through a two-dimensional set of points. So that's what it's doing. Now, rather than use that same donor data set that you've been learning and using with your SAS Enterprise Minor 13.1 walkthrough, I've switched to the RETEN 7 SAS data set. I think a couple of you even used this in your first assignment. It's an interesting data set. It's a set that has a reasonable number of cases, a nice number of variables, and it's sort of intuitive in the sense that most of what's in it we sort of have a grasp for. You're basically trying to estimate the odds, because this is going to be a regression, a logistic regression, so we're not predicting a continuous variable, we're predicting a yes or no. 0 means they did return to school and didn't churn or defect. It's almost a churn model, isn't it? Because if you get a 1, that means they didn't return, they churned. They went to a different college, campus, different stage of life, whatever. But it's a nice little tidy data set, and I decided to use it for this little walkthrough. It's got 20 features, which could be used as predictors. I'll say a little bit more about those in a minute. And we're trying to estimate the odds, because that's what you do with a logistic regression. You don't exactly get a formula where each of the coefficients is a specific amount that the continuous target changes. If you add one additional unit of that input variable, you get something a little different. As we talked about last week, you get this logistic formula that basically are the odds of something being in either this pot or this pot. Okay, so let me see if I can continue to go back and forth effectively. Here I am in the data set. You can see my model's all built. Of course, you would build this piece by piece, but in order to save time, I can't keep you here all night because we're starting late. My fault for that. I had a commitment earlier. So anyway, we're got the model built, but we'll walk through it. Okay, one of the first things reminder is that under options preferences, if it's a small reason, well, for any data set, I would set this to random and this to max, just so you bring in the maximum amount of data. If it's, bigger than the 30, 35,000 cases that it'll hold, it'll just bring in that many. Remember that the default setting is top, and the default number is a much smaller number. So, if you haven't already set that, that's one of the recommendations I would say. You only have to do that once. It should stay that way every time you come in. Okay, so the first thing, of course, I did was drag this, well, after setting up the libraries appropriately and all, was drag, and creating a diagram, was drag the retention 7 data set into my diagram. Now, you can actually click on the retain 7 data set right over here and click Explore right from here. This is a little different from Stat Explorer. And let's see, where are all my, shoot, what happened here? I thought I still had the results windows open, but apparently not. So it's going to load this. This Explorer, there it is. This Explorer is pretty nice. Gives you a quick look at your data set. Now, you could have looked at it in SAS Studio before you decided to use it, but maybe you didn't. Maybe you want to look at it here. So, here are your variables. There are your 20 variables with, of course, one that's a target. And then here are the cases. Remember, we've got 2,626 cases. Okay. Of course, there's a lot more over here, so forth, a lot more variables, and just some features and facts and so forth about it. So that's kind of nice. You get a quick look at your data just in case you've been gone from it for a few days, like I was. And you want to come back and say, oh, yeah, what's in there? I do need to know what it is I'm looking at here, right? Okay. All right, so that, I'm going to close that. So all I did was drag it over, again, right-click here in that. Now, let me go back to my PowerPoint. I'm trying to go back and forth. All right. Then I put a Stat Explorer node in. It's always good. Most of you did that in the first assignment. It's always good to get a Stat Explorer node. And I thought my results were open on this too. I don't know where all my results went. Let me see. I thought I had results open. Yeah, here we are. The result, they're open. I just can't get them to come up at the bottom of the screen because of our recording in WebEx, apparently. So again, you run the Stat Explorer, and then when you look at results here, you get, of course, a chi-square plot for the discrete variables and the variable worth for the continuous variables, and gives you some feel, as you know, for which variables are going to likely have the most impact on the results. Remember, that's looking at them individually. It doesn't necessarily mean that collectively, when you mix variables, that's going to turn out that way. And often it doesn't. But you sure have a feel for, wow, transcript, isn't that an interesting one? Fall GPA turns out to be the most influential. And that makes sense, doesn't it, intuitively? If you have a high GPA, you're likely to come back to the school. You like that school. If you have a low GPA, you may not be invited back, or you may not want to come back. Okay, so let me close that too. All right, well, we haven't got to this yet. Okay. So there's a Stat Explorer. I just stuck that in there, and so of course you have some settings over here on that if you want to take a look at things and turn some things off and on, but that's pretty basic. The default settings there work pretty well, I think. All right, so the next thing that I decided to do was partition the data, okay, and I changed the defaults. Let me get back to my PowerPoint. I'm not sure why I'm on that slide. Okay, maybe I went too far ahead. Oh, these are some settings you can do when you first get in there to make sure that it doesn't treat, I recommend changing these settings so that it doesn't treat excessive missing variables. Remember, it's going to say, well, if it's missing a certain percentage, then I won't count that variable. And if it's got a certain number of counts, I won't count it. And if it's got a certain number of classes, I'll treat it as a discontinuous variable. So you might want to change those. You can look at these slides and see what I suggested. Okay. So now we have the partition, and a very simple thing. I changed it from the defaults to 60/40. Again, I normally only use two sets, a training set and a validation set. And you can vary these numbers a little bit, but I've not yet glommed onto using that third set very effectively, so I use two. Okay. So we've put our data set in, we've done a stat explorer, we've done a data partition. The next thing you would normally do would be, okay, since this is a regression model, and with regression and neural network models, as you know, we need to make sure we have relatively smooth distributions for our continuous variables. Okay, before I transform, I'm going to go back to retention, and I'm going to click let's see, the retention variable, and then you come over here, okay, to the retention. They got lots of settings, as you know, right? Okay, so if you want to look at variables, you can look at them here. And there they are. Now, again, why am I doing this? Well, I'm looking at some of them here, and I'm going to go highlight the interval ones just to see a little bit about what their shape is. So if you highlight a lot of interval variables in here, okay, and then say, now, so I used the control key and clicked on all the interval variables, so you can see they're sort of a different color, okay, and then I click on explore. And this is a very useful thing to do. Hopefully it won't take too long. I think I may have had this one open already too, but I didn't. I thought I had everything open, ready to roll, but apparently I either didn't or I forgot to leave it open. But it'll come up in a minute. And there we are. We have the little histograms of all of the variables. So again, this lets you get a peek to see which of these look skewed. Okay, well, this one certainly does. This one does. Some are skewed positive, some are skewed negative. But many of them are certainly skewed, and as you know from our discussion and your readings, dealing with skewed variables, you have to do something about that. Now, the SAT one looks okay, not bad, right? Doesn't look too bad. But these others look kind of skewed, so we may have to transform virtually all the variables except maybe SAT. It wouldn't hurt to transform SAT. Now, you know, I mentioned to some of you in the feedback, most people would think, well, why not always transform variables? Well, you know, in the case of a decision tree, as I mentioned to a few of you, if you had a rule that said if age is greater than 45, then the result is they make over $100,000. Okay, well, that's fine. But if you transform that variable and age, instead of age gets transformed into the log of base 10 of age, well, now the rule is going to be a little messier to interpret, isn't it? So again, the transformation does come at a little bit of a price. Now, you don't see that written up too much, but I would consider that somewhat of a penalty. Again, if it works and improves the model greatly, fine. But now you got a rule that says if the log to base 10 of the age is greater than a certain number, and then most people have forgotten all they ever knew about logs and things like that, so it makes it a little bit messier. But that doesn't negate the fact that transformations need to be done for regression and neural nets, especially for highly skewed variables. And so we're going to get a lot of different stuff here, aren't we? Okay, so I was basically looking at that first before I did any transformations. So we've looked at the retention model. We've seen what's in there. We've partitioned the data. We did a little stat exploration. We're getting ready now to transform the variables. All right, now when you click on these, as you know, you get lots of settings over here. Okay, and so one of the first things you want to do is sort of figure out which of the variables are you going to transform. Okay, so we come back over here to our variables. All right. Click on the variables again. There they are. And these would all say, when you first start, these are all going to say default. They're not going to say max normal. Okay? So I probably should have changed those back. They all said default. And again, these are the continuous variables, the ones I wanted. The interval variables are the ones I'm concerned about. So basically, you would click these and say what you want to do to them. You would change it from default to whatever you want. You want exponential, inverse, log 10, max normal is the one that I use. And I'll tell you why in a second. So let me start over here. I hit the wrong button. Key, boom, 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 boom. And I'll just leave SAT alone as the default because you could transform, but no need to. So going back to the PowerPoint, we got the transformation here. So again, there are a lot of different transformations you can use. Best, multiple, log, log 10, square root, inverse, square, exponent, la, 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 la. Okay? These are interval transformations. Okay? And these are interval variables that we're dealing with at the moment. So, let's see, I thought I had something here talking about that. Here are, yeah, click on variables. Here they come up. And, you know, all the interval variables that we want to transform. Here's what they look like. Remember, they were all fairly skewed, except for maybe SAT. And here's what it looks like before you change the default, because default means no transformation. And then here's what it looks like when you put the max normal in. And here's what came out of the explanation of what the max normal does. Now, the max normal is a very powerful option, I think, because it basically looks at several different transformations for each of the variables. It doesn't have to apply the same transformation to all of them. You can apply a different transformation to each variable if that's appropriate. But basically, it tries all of these transformations you see right here for each of the variables. X, log x, square root of x, e to the x, x to the 1/4, x squared, and x to the 4th. You know, that's quite a few, you know, and you're doing that for each variable, and then you're selecting the transformation from that set, which turns the distribution into the most like a normal distribution based on the 4 bins, okay, the quantiles. So that's probably a very powerful one to use, isn't it? I can't guarantee it'll always be the best, but, you know, it's probably the best to start with, okay? All right, so now we've transformed the variables, right? Let's look at the results. Here are the results. Now, how do I interpret this? Well, again, here are my original variables. These are, again, the interval variables. And here are the new ones. So you can see it used an exponent here, a log here, a power here, a square root here, and so forth. So it used different transformations on different variables. Again, it tried them all and picked the best one for each of the variables. And one of the ways you can check and see how much things improved, of course, would be to look at the skewness. So here's age. The skewness before it was transformed was 19. If we come down here and find the new one, age transform, you can see it's been reduced from 19 to 3. That's pretty significant, isn't it? It could be. It certainly made it smoother. And so for virtually all of them, there should be a lessening of the skewness. Distance, 4.02. Square root of distance, 1.87. So by reducing the skewness, we've made the distribution smoother. That's what the whole intent was. And, of course, we have a lot of other numbers here to help us with that. But basically, the skewness is the key thing we're reducing. So it's closer to normal. And, again, you could do more, try other transformations if you so choose, okay? So you could try other transformations if you wished, but I don't know if you need to do that. If the model doesn't turn out well, then that might be one of the things you'd want to go back and do slightly differently. It's a lot of fun to play with these models. Now, one of the things I mentioned to several of you is you need to keep track of all the settings you used each time you build a model. And actually, the way it works with regression, as you'll see when we get to the regression, and most of you know this probably already from practice and building some, is the regression equation will build multiple models for this one sort of set of settings, if you will, especially if you're using stepwise, because it keeps track of each time it puts something in, takes something out. So it's kind of interesting. So you almost get multiple models with these settings. Then you can go back and change some of your settings and basically change some of your transformations. Maybe change the way the regression models are built. Instead of stepwise, build the forward selection or backward elimination, and see with the same settings what kind of models you get that way. Okay. Impute. Now again, you'll see these are not the defaults. Tree surrogate and tree surrogate are the models or the approaches I picked for both the class and the interval variables to impute missing values. As you know, you have a lot of choices for imputing missing values. Well, this is showing, by the way, once you've done the transformation, you can go in and take a look at the exported variables, which is what comes out after they've been transformed, and you can plot those and see if they do look a little better shape. Here's one. This was the distance that got changed into square root of distance. So you can see if that looks better. Of course, it does look a little better, and the skewness number is better. So you know it's better, right? May not be perfect, but it's better. Okay. So when we get to imputing, okay, these are the defaults: count and mean. So that means if you're missing an interval variable, it's going to put the mean of that variable in for any missing values. And same thing similarly for the class variable, it's going to use the count. Well, again, when you start exploring your options, you click on some of the pull downs and the ellipses and things like that, and you find you have all kinds of stuff here, don't you? And then you go read, because the help screens are quite good, I think. So if you say, what in the world is tree surrogate? You know, try that. You know, it basically tells you about what these things are. Okay, so if you read about tree surrogate, and here it is. Replacement values are estimated by analyzing each input as a target. Well, that's really unusual, isn't it? So we take the input, which is usually an input to predict some other target, and we call it the target. And the other inputs and rejected variables are used to predict this missing input. Isn't that interesting? Okay. Variables that have a model role of target cannot be used to input the data. So the target is not used. Okay. So we're basically using predicting the value that's missing by using the other variables, which I find fascinating. And tree surrogate's the same, except it has some splitting rules in there. So I think that's an interesting one to use. So I use that for this little walkthrough that I did. If I get this help screen to go away, that'd be even better. I can't. I think I can. So, whoops. So that's what I'm pointing out here. Instead of using this here, these defaults rather, I went and used tree surrogate. Okay. So I changed those to tree surrogate. Okay. And now we have how I can get my help screen. There we go. Okay. So now we've done partitioning. We've looked at it. We've transformed a reasonable way. We've imputed. We're finally over to regression. Okay, you can see it all figured out. Well, this is a logistic regression because of the answer is, you know, discrete, yes, 0, 1, yes, no. But there were some other settings that I found interesting. And several of the books I use for my background and my training have mentioned that what you want to do with regression, and of course this was different when you had to calculate all the calculations tediously. In those cases, remember, we've had a sea change. When you were building regression models the old-fashioned way, the way I did it in my doctoral program, for example, you thought long and hard based on some preliminary statistics and things about which variables you wanted to put in the equation, because it was very cumbersome to calculate all the kinds of things you had to do to get the actual equation. So, you know, you looked at the variables, you agonized over it, you tried to think about intuitively what's a good combination. You made it very small number of variables, and we still want to have, remember, the smallest model that works the best, so still want to be parsimonious with our inputs. But we now are in a different environment where, because of the immense power of most of the high-end modeling tools, such as SAS Enterprise Miner, we can build multiple models rather quickly. So my thinking has flip-flopped on this. Why not make it easy for a model, for a variable to enter into the model, and easy to stay in, because you're going to test that model on validation set anyway. So if it turns out it's not any good, it'll move on to some other model, right? So if you look at the defaults that I picked, I changed them, okay? These, first of all, I picked for the method I wanted to use. Let's see if I got regression highlighted. Yes. I picked stepwise. You can do backward, forward, or none. None, you would have to pick whatever you want in there. But stepwise, remember, as we talked about last week, can both put variables in and take them out with each step. And each step, think of each step as basically a new model, because that's what it is. It is a new model because it has a different set of variables in it. And of course, every time it does a step, it calculates how well it does against the validation set. So that's kind of neat. So stepwise is a good start. You can always go back and try backward and forward, but stepwise is what I picked. And the criterion, validation error. And then let's look at these things. Under the selection options, there's an ellipsis. And as you know by now, when you click on ellipsis, you get more submenus. So the defaults were to have an entry significance level of 0.05 and a stay significance level of 0.05, which are pretty tough levels. You got to be really good variable to get in there, and you got to be really good to stay. And the maximum number step 0. So it's going to build very few models. So if you change this, make the significance level higher, meaning it's much easier for a variable to be significant and be included, and change the stay level higher, 0.05, this is 10 times higher, this is 20 times higher. It's much easier for a variable to stay in the model. So think about what we're doing. We're making it easier for variables to come into the model, because they might be good ones, and we're making it easier to stay. They might be good ones. And when we say 30 steps, that's basically going to build up to 30 models. So again, a different approach, something to think about, because why not build multiple models? They all get tested, as you find out when you build regression models. So that was a couple of very interesting things I did when I did this little model. Okay. So eventually you will get the answer, right? So I've already run mine clearly, because you see the little green check marks here. So let's look at the results. And of course, the regression model runs relatively quickly, even though it's building many, many models. Okay, each step being basically a separate model. So I think it'll pull the results up relatively quickly. You know, I find SAS Enterprise Miner works relatively quickly once you get into it and get it going. I've had mine open since about 3 o'clock this afternoon. It's been running quite nicely. Okay, so it did a bunch of stuff here. And now we end up with, this is the best model. The best model is going to be this one with these variables in it. Only one of them is positive, and that's the intercept. The rest are negative. Okay. This is imputed power high school rate. Again, when you change variables, you get some strange stuff sometimes to explain. And this is, of course, the stats on it, okay, showing you the best of the model, okay. Now, I had a very good question occur in the discussion area, which I tried to answer this afternoon, because it was also a question that I had trouble with when I first started doing this last semester. And that is, okay, here I know what's in the model. I know the factors that are in the model. What I don't know easily, although I can pull them out by hovering over them, are the coefficients. I'd like to see all that written out, because it basically is a formula, as you know. Where the heck is that? Well, SAS made that a little bit more difficult to find than they needed to, in my opinion. It's over here in output. Okay, if you maximize output and start scrolling down, basically you see each step that it took and what happened. and how well the model performed, lots of stuff. Okay, and of course variables are coming in, variables are going out. If you want to follow through and watch this, that's great. But what you may be really interested in is of course, the answer. So if you go in here to edit, find. This is the key. This is the most important thing I'll tell you tonight, probably, if you want to find your answer. If you go to edit and go find and type in selected model and say find next, it will take you to the model that is the winner. And you'll notice that occurred at line 2,613 of the final answer. So that would have been tough to kind of scroll through and just luck into, right? So here it is. Remember, these are the variables that are in it. They call them effects. These are the variables that are in it. Okay. And of course, these are the coefficients. So it's 5.8910 minus this, minus 1.7794 this, minus 8 this, and so forth and so on, to get the number that then converts into a yes or a no, whether they'll come back, probability. Okay. So it's there. It's just a little difficult to sometimes find. And then, of course, if you want to see all the stats, there they are. Okay. And then there's a classification table. Also very good, right? Of course, the classification table is something we use quite a bit with logistic regression or any kind of categorical supervised model. You want to know how many you got right, how many you got wrong, how well is it doing, how many false positives, how many false negatives, both against the training set and against the validation set. Now remember, these numbers should be pretty close. Usually a little bit, well, usually almost always, or it should almost always be worse on the validation set. It could be a fluke where it just lucked out and did well on the validation set, but usually it's worse. So here it's 92% correct on the zeros, meaning the people who did return. Here it's 91 and change. That's very close. And then here it's 78% correct, predicting those who will churn or leave. And here it's 75%. Again, pretty close. Remember, if there's a large discrepancy, and that word large is relatively undefined, somewhat subjective. If there's a large discrepancy between the accuracy of the training set and the accuracy of the test set, you likely have overfit to the training set. But we always, always, always have a training set and a test set, or a training set and a validation set in this case. And so we are able to compare these things and take a look. Okay? So there's a lot of stuff in here, but they made it, you know, it's buried in this output file. Okay. Now you also get, go back. You also get, let me go back, right, PowerPoint. Okay. This shows you, now this, I had some slightly different settings. So this one built a lot of different models. This one only built that many models, 6 models. Oh, these are the answers, I'm sorry. Let's see, where's my number of models? Oh, here it is. Okay. This, you can go and do an iteration plot. Okay, so let me go back to my regression, my results. I think my results are still open, but if not, let me get them open again. View, model. So view, model, iteration plot. This is a very powerful thing to look at, similar to what we did with decision trees, because this will tell you where the best model occurred. The best model occurred with the 5th iteration. Again, remember, each iteration I'm putting a variable in and thinking about taking a variable out with the stepwise. So the 5th one was the best one. Of course, that's always based on the validation squared error being the lowest of all the models, as opposed to the training set, of course, continues to get better and better, but the validation bottomed out or got the best with the 5th model that was built. Okay? The average squared error, which is a common measure of accuracy for regression models. So there it was. When I built this model with some different settings, actually the best model occurred at iteration 13. And this is what's curious. Look how many factors were in the best model this time. This is the same data set. Same data set, just some different settings. And of course, you start putting variables in different ways. I'm trying to remember exactly what I changed, but I got some different settings. I need to go back and look at my table I had. But you can see this one ended up with a lot of factors. 1, 2, 3, 4, quite a few. Well, there they are. Okay. I think I did something different with the imputing the missing values, as I recall. And I may have done some different transformations. Which model is best? Well, again, you'd have to go back to the overall error rate and certainly the classification table if it were important to have a penalty for false positives and or false negatives. You'd want to look at that and figure that out. And again, you can set that criteria. You can say, I want to make it minimum costs and so forth, and put those cost figures in just like you could for any data set. As I said before, I really wish we had problems that did have cost figures, penalties for false positives and false negatives, because that moves it more from a modeling thing to a business problem. But it's probably useful to build it just as a model and then go back and say, okay, now someone has just supplied me with some cost figures. Let me go see if that makes a difference in which of the iterations is best. Because, again, there might be something that's not as good on the overall classification error rate, is better at not having false positives or false negatives. Obviously, you can't have both minimized, but you can minimize one or the other. And so when you put the cost figures in, you may change your mind about which of the many models you want to use. Of course, with SAS, that's pretty easy to do. Go back to the metadata and put those cost numbers in. So what I'm trying to do is plan ahead probably for next semester and come up with some cost figures for many of the problem sets, and then assign the problem sets, but not give the cost figures. Because unless you see some value in giving the cost figures initially, I see value in building the model, then going back and say, oh, by the way, the accounting department just gave me some cost figures for false positives, false negatives, and maybe even some figures for getting things right, payoffs, profits. Now, which model do you want? And see, I think that would be a valuable learning tool. Because I think if you have the cost figures first, kind of like SARMA does, you lose a little bit of the learning curve in the sense of knowing which model is absolutely the best based on purely the model characteristics. So anyway, if you all have thoughts on that, send them to me separately in an email, because I'm trying to design a little bit more related to the business case. Okay, so again, false positives, false negatives. All right, so, that's what I did. And you could do, again, go back and build another set and put another set of variables in there, or move this up and put another regression equation here if you wanted to just do something different with the regression. Or if you want to change some of these things, as you know, you can add a different transformation node here. You can do something different with imputation. So you can build a pretty complicated diagram, or you can have, if you don't want to do that, multiple diagrams, okay? Separate diagrams. So either way is fine. And again, I would put some of that, you want to be able to summarize what you did, because it's important to keep track of that. Oh, in this setting, here are all the different settings I did, or here's where I changed things. And so it's very important to keep track of that as a data analyst. I think it could be easily confusing if you start just willy-nilly trying things, and then you say, oh, this is a good model, I wonder what I did. You can go back and trace most of that, but you can't really compare it too easily with the others. Okay, so the general process. What is the general process? It's the same as we've said before. Build a model on the training data, assess it on the test data or validation data. Then go back, because you have this luxury of this very nice software, and change some of the key settings, some of the key parameters, maybe even change the inputs. You can try forward selection, you can try stepwise, you can try backward elimination. Remember, backward elimination puts all the variables in it and then takes them out, and see how those compare. It certainly would be an interesting thing. Or you can just say none and put them in yourself, decide which variables you want to do. So when you do that, of course, you're rebuilding the model based on the training data, and you're assessing again on the testing data, and that's pretty well automated. You may want to use the third set for some reason. Again, change, and then just basically rinse and repeat, like it says in the shampoo bottle. Let's go back and change some more things. And again, eventually you, of course, run out of time and energy, obviously, or you get a model that is perhaps so complicated that it's not, if it's only marginally better than a simple model. For example, the two models I have there, one has just 4 or 5 factors, one has 13. If you took a quick look at the accuracy, you saw that they were very comparable, almost, less than half a percent difference. So I would probably want to use the simpler model. Remember, one of our early guidance we talked about was the simplest, most accurate model, and that's a trade-off. More complexity means you got to collect more variables. You got to keep track of what the transform values are, all of which, of course, the software helps with. But why not deal with a simpler model if you're going to try to explain, especially if you get some crazy combinations showing up in some of the models that don't seem to make intuitive sense. Does it really make sense to predict whether someone's going to come back to your college based on whether they live in the dorm or whether they belong to a sorority or fraternity? Or maybe it does. You might be able to make an argument for that. So then you evaluate all the models, determine the best ones. I said best is a combination of simplicity, feature parsimony, ease of explanation, technique, and so forth. So, that's basically our overall guidance. And so I wanted to at least show you that one walkthrough that seemed to work reasonably well. Okay, again, the keys: try to find a robust data set. You'd like to have a data set that has lots of cases, and of course, you don't necessarily need millions. We're not at the Teradata yet, although SAS can handle Teradata. We'll get to that later in the course. But you would like to have something with at least several thousands, because again, the more data you have, assuming it covers a wide variety of the variables and a wide variety of the values of the variables in combination, then the more likely you are to find a good model fit out of that. You want to transform the variables that are skewed. Okay, that's again a judgment call. How much skewedness do I need? Oh, you know what? I think my second model I may have transformed SAT, as I recall. I have to go back and look. I do keep track of things, but I didn't have it with me tonight. You want to impute the missing values for the used variables. For the missing variable, you impute the missing values for the variables that you're going to use. That's what I meant to say. You want to choose a method for your regression. Again, the 3 key ones: stepwise, forward, backward elimination. But you can do others. You can just do your own. And then you want to evaluate the results and sort of write all that up in a nice, interesting way. Again, we're trying to accomplish 2 goals. We're trying to make sure you understand what regression really is, and we're trying to make sure that you have some facile ability with SAS Enterprise Miner, which is a very powerful package and has a lot of bells and whistles, which we don't get to all of those. And if you find an interesting bell or whistle, and you use it, and it does something unique or interesting, research it a little bit and write it up and include it in your paper, or if it's something you didn't include but you still thought it was interesting, put it in the discussion area or somewhere there. Okay, so what are you going to do for weeks 7 and 8, this being week 7, the start of week 7? And I tried to clarify again, if you haven't looked at the discussion, something I hadn't clarified well enough in the syllabus. When it shows in the syllabus that an assignment is due, it's due at the end of that week. But I also need to amend that our weeks go from Tuesday to Monday, except for the last week of the course. So the syllabus was slightly off because I had other courses that I teach on Monday. So we're going Tuesday to Monday. So in essence, the assignment is due midnight Monday, but because of the 4th of July, I'm pushing it to Tuesday. And if anybody has a real problem with that, then we'll worry about that. Week 8, we will start our third area of interest of the big 3: decision trees, regression, and neural nets, the 3 big modeling tools for predictive modeling. And then, of course, after we get done with that, which will be weeks 8 and 9, we'll come back and look at a couple of things. Ensembles, which is a way of building multiple models. And many of you already did that when you built the gradient boost in the decision tree. That was really an ensemble model. I don't know why SAS doesn't put it there, but that's the way it is. We'll also talk about why not build models with all of the methods and then sort that out. same as building multiple regression models. Why not build a neural net, a regression, a decision tree on the same problem and sort all that out? So there's a lot of things you can do in there. We'll also talk about text mining. That's unstructured text is about 80–85% of the data in the world. So we'll talk a little bit about text mining. SAS can do a lot of that. We won't do any of it in this course, but we'll hit on it and talk about it. And of course, as always, if you have an interesting observation, experience, insight, tip, problem, question, put it somewhere in the discussion area. And I do appreciate those of you who weigh in and help answer some of those questions. Some of you have more experience in this area than others, so weigh in if you have an answer and have discovered it. Certainly weighing in and providing that in the discussion area is a great way to go so everyone gets to see it. So read the discussion, take a look. It tells you when there's new stuff there. Our final, I better put the chat in the where is it? Chat room back up. Participants, I better put those back up. So this is a final slide as always. If you have a question that's burning right now, you can ask. It's 10:20. And of course, during the week, I try to answer questions as quickly as I can. If it's something of interest to all, that's where it goes in the discussion area. If it's just for you, then email or phone call. Sorry we had to do it late tonight. I have a relative getting married, not an immediate relative in my family, but I'm in the wedding, and tonight was the wedding rehearsal, so I had to go to that. They didn't seem to understand that I had to teach. Okay, so I think we're well on our way. Oh, discussion post said Wednesday, July 8th. Aha, Paul. Good. Well, if the discussion post said Wednesday, July 8th, I will go with Wednesday, July 8th. Sorry. I think I had considered delaying it one day, and then when I saw it in the discussion area, I think I decided to go with 2 days. So let me amend everything I've said about the due date. It will be Wednesday, July 8th. You can thank Paul for pointing that out. That's fine. Yeah, there's no penalty for turning your assignment in early. So Wednesday, July 8th. Will be the absolute deadline. Of course, if you take those extra days to do that assignment, you short sheet yourself, so to speak, on the next assignment because it will remain due on July 20th, 2 weeks from the 6th. Okay, that will be the neural network one. We'll get to that. Don't worry about the neural net yet. But, again, there's no free lunch here. If you take extra time for this one, then, of course, you have a lesser time for the next one. And ultimately, downstream, everything flows. Okay, good question. Now, sorry I confused you. I meant to make that July 7th, but I said the 8th, so I'll stick with it. So the 8th will be fine. Okay, great. All right, well, let me go and do my usual thing, which is first of all, stop sharing and close some of these. I can finally close SAS, I think. It worked fairly well. And then I go back here, and now I need to stop the recorder.